In this next example, we're given a graph and we are supposed to come up with the equation for that graph. So the first thing you might notice is this graph is a parabola. So that means the parent function will be a quadratic, or x squared. I recommend starting by graphing the parent function on the same graph that is given. So we would have 0, 0 as our vertex, the point 1, 1, negative 1, 1, and then 2, 4, so it would go up in this direction, pardon my drawing. Once we graph the parent function, we can compare some important points. In a parabola, a very important point would be the vertex. The vertex doesn't change, it's always the tip of that parabola, either max or min. So we find its matching value on the new graph and see how it's been shifted. So we may notice that that vertex moved right 2 units. So that means we have a change in x. And remember that x, that inside change, works the opposite way that we think. So if it moves right, we are actually subtracting 2 units from the x. And then to get to that new vertex, it goes down 3 units. So that's a change in our y, and y works the way we want to. So we subtract 3. You may also notice if we moved that blue graph down to where the red is, it would be here because it was over 1, up 1, over 1, up 1. So there is some sort of stretch or compress with this function. Now, oftentimes it's hard to tell whether or not, is it a horizontal stretch? Is it a vertical stretch? I would always look for the vertical stretch. In other words, that outside change. If you start trying to make it a horizontal stretch, you're going to change with the x, which means you have to change that -2. So we're going to look and see if there is an a being multiplied by the entire function on the outside. Now, just by looking at it, it's really difficult to tell how that's changed because we don't really know what this y value is. We can guess maybe it's, -2.5, but we're not sure. But notice in this equation, we have 3 unknown variables. We have y, we have a, we have x. Wouldn't it be nice if we knew values for x and y on that new equation or that new graph that we could plug in and just solve for our a? Well, we do. So look on the graph in red and try to find at least one point where you know exactly what the x and y values are. For example, at this vertex, it's right there at that hash mark. So we know that x is 2 and the y is -3. There's another point here right at a hash mark where x is 4, y is -1. And over here where x is 0, y is -1. All of these are x, y values that are on the graph. And remember, any point on the graph is a solution to the equation. That's where all the x and y's come from. So we can choose any of those x and y's. And let's say we're choosing 4, -1. And we can plug those in for x and y and then solve. So if y is -1, we have a times 4 minus 2 squared minus 3. -1 equals a times 2 squared minus 3. So -1 equals 4a minus 3. Add that 3 to both sides. We get 2 equals 4a. So our a would be 1/2. Now remember, that's not the entire equation. We have to plug that back into this guy. So the equation for the red graph, we can call it g of x, because we already used f of x for our parent function. We can say g of x equals 1/2 times x minus 2 squared minus 3.